What's up guys, welcome back to my new video. So in this video we're going to talk about the Radix Sort. So ever wondered how numbers got sorted without even comparing them? Yes, that is the Radix Sort. So Radix Sort is non-comparison sorting algorithm. It sorts numbers digit by digit, not by checking which number is bigger. For an example, like instead of asking is 23 bigger than 45, the Radix Sort just look at the digits. So the purpose of Radix Sort is to sort large set of integers or fixed length strings more efficiently, especially when numbers have a limited number of digits, and also when you want sorting faster than comparison sorts in practice. Okay, so the Radix Sort follows the digit by digit sorting method. So we consider the place value of the digits. So right here for an example, we got 421. So you can see the 1 is at the 1th place and the 2 is at the 10th place and the 4 is at the 100th place. So likewise, this makes the this value 421. So to sort, we starting from the least significant digit and move forward to the most significant digit. So you can see the 1 which is at the 1th place. So this is going to be the least significant digit, and the 4 is at the 100th place, so which is the most significant digit. So to sort an array, we are using some method called the bucket sorting. So basically the radix means the base. So also we are dealing with the decimal numbers here, and then the 10 is the base for the decimal numbers. So therefore we are using 10 buckets starting from the 0 to 9, and then follows some rules. So as you can see, here we got some steps to sort an array using Radix Sort. So the first thing is we have to find the maximum number. So for an example, just think 421 is the maximum number of some array. Then we have to count how many digits are there in that number. So for an example, let's take the 421 is the maximum number. So we got 3 digits in this number. So and then we have to make all the numbers as the 3 digits numbers, because our maximum number got 3 digits. So we are going to make all the elements as a 3 digit number by adding zeros to the left side. So the third step is we have to make all the numbers as the 3 digit number. Like for an example, 421 is the maximum number of some kind of array. Then this got 3 digits. Therefore, we are going to make all the other numbers as 3 digit numbers. So by adding zeros to the left side, we are adding zeros to the left side because we don't want to change the value of the number. We only need to adding zeros to the left side because we are using some kind of particular sorting method to sort this array. So therefore, we are using this method. So the string method. Okay, so whenever we are talking about the string method, the base is 26 for alphabets. So we are using 26 buckets starting from 0 to 25. Okay, so the sorting method of strings is something like this. So you can see we got a Benjamin right here and Billy right here. So in the string method, we are starting from the most significant bit and then compare the other bits. Like for an example, right here, you can see the Benjamin and Billy. So the B is the most significant bit, and also right here the B is the most significant bit because they both got the B. So because the both having B, we are looking to the second element, which is the second most significant bit. So you can see this got the Benjamin got the E and the Billy got the I. So obviously the E is comes first, then the I. So therefore the Benjamin comes first, then Billy. So this is the method that we are using for the strings. Okay, so to sort an array, so the first thing is we have to look at the array first. and then find out the what is the maximum value. So in this case, the 321 is the maximum value, and then we have to identify the digits of this value. So you can see there's 3 digits in this value, and then we have to change the entire array as in 3 digit numbers, like you know what I'm saying. So for that we're gonna add zeros to the left side, so then we got 3 digit numbers. So and also that won't change the value of the number. So we have the buckets right here, the starting from 0 to the 9, and we got 10 buckets right here. So for the past one, we're going to look at the 1th place of the numbers from the array. So which means the least significant digit, which is at the 1th place. So we are starting from the 15. So we are starting from here to here, which means all the way up to here. So we're starting from the 15s, and then 1, and then this likewise. Okay, so now what we're gonna do is we're gonna fill these buckets. So now we got 3 digit arrays. So now we have done changing the arrays to the 3 digit numbers. So what we're gonna do is we're gonna look at the first number. So we are starting from right here. So we got 15. So we're gonna look at the least significant digit, which is the 5, which is at the 1th place. So because the 5 is at the 1th place, we're gonna add this value to the 5th bucket. So you can see we got this right here. So likewise for the 1, 1 is at the 1st place, therefore we are going to add the 1 to the 1st bucket. So you can see right here, and likewise the 321 is go to the 1st bucket because of the 1 is at the 1th place. So for the 10, the 0 is the least significant digit, so we are going to add the 10 for the 0 bucket, and then the 3 is going to the 3rd bucket, and then the 52 is going to the 2nd bucket, and then the 90 goes right here, and the 011 goes to the right here. Now we are done storing the values to the our buckets. So now what we're going to do is we are going to extract this value, and then combine these values to an array. So what we're going to do is starting from right here, so this is the starting point, and then likewise so we are starting from the 10, and then 90, and then 01, and then 321, and then 011. Likewise we are adding the values, these values to this array. So the 10 goes first, and then 90 goes, and then 1, and then 121, and then 11, and then 52, and then 123, and then 15. So you can see we are done here. So we are moved to the past 2. So right here what we're going to do is we're going to fill these buckets using this array, not using the default array. uh, so only we are looking at this array. So for the past 2, we're going to use the this array uh, that we created using the past 1. So according to this array, now we are looking at the 10th place, which means the second element. So for example, our first element is the 0, 10, the second element. So this is the element that we are looking. So we are looking at the 10th place. So we are starting from here, and then all the way up to here. Okay, so the first value we got 0, 10. So we are looking at the second element. So in this case we got 1 for the second place, then the 1 goes to the first bucket, you can see, and then 9 goes to the 9th bucket, and then 1, sorry, and then 0, this goes to the 0 bucket, and then the 2 goes to the second bucket, and then this 1 goes to the 1 bucket, and then this 5 goes to the 5th bucket, and then this 2 goes to the second bucket, and then this 1 goes to the first bucket. So now we are done uh, storing the values to the buckets. Now we're going to extract these values and then combine these values to an array. So starting from here to here, we are starting from 001 and all the way down to the 019. So 001 going first, and then the 10, and then the 11, and then the 15, and then 321, and then 123, and then 52, and then 90. So we are done here. Okay, in the past 3 we are looking at the 100 place. Okay, so for 0001 we are looking at this digit, which is the most significant digit. Okay, so likewise we're going to fill this up. Okay, so starting from here and then all the way up to here. Okay, so we are looking at the most significant bit. So the 0 goes right here, and this 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 3 goes right here, and then this 1 goes right here, and then this 0 goes here, and this 0 goes here. Okay, so now we are done storing the values. Now we are going to extract these values and then combine the values to an array. So starting from here, so we got 001 first, and then 10, and then 11, and then 15, and then 52, and then 090, and then 123, and then 321. Okay, so right now what we're going to do is we're going to remove those zeros from the array. Okay, and then we got the final answer, which is the sorted array using Radix Sort. So this is the sorted array using the Radix Sort. Okay, so Radix Sort is called non-comparison based sorting algorithm because it does not compare elements with each other, like this number is bigger than that number, like instead it looks at individual digits of numbers and then sorts them digit by digit according to ones place, tens place, 100 place, likewise. So in comparison based algorithms like bubble sort, quick sort, merge sort, we repeatedly compare two elements, but in Radix sort, we group numbers based on the value of the digits. Because the Radix sort avoid comparisons, it can sort data fast when the number of digits is limited. So Radix sort is non-comparison based because it organizes elements by digit positions rather than comparing the actual values.